Good morning. I wanted to talk to you about energy density, negative energy density, and exotic matter. Energy density is a measure of the amount of energy stored in a given system or region of space per unit volume. It's a fundamental concept in various fields of physics and engineering, providing insights into how energy is distributed and how it gets utilized in different contexts. Let's go into a detailed overview. We start with a definition. Energy density quantifies the energy contained, in a physical system relative to its volume. It's typically expressed in units of joules per cubic meter. In other words, large J over small m to the third power, which is in the International System of Units we know as SI. The higher the energy density, the more the energy is stored in a given volume. What are some types of energy density? Well, the first type we have is volumetric, which is very straightforward because it's basically measuring by volume. This refers to the amount of energy per unit volume. This is the most common form and is used to describe the energy storage in batteries, fuels, and other materials. We also have gravimetric energy density, which is known as specific energy, and it refers to the amount of energy per unit mass, which is usually expressed in joules per kilogram, right? J over kilogram, right? This measure is particularly relevant for portable energy sources where weight is a critical factor, right? Because if you keep increasing the amount of kilograms, it weighs more. You don't want to be lugging around this huge store of energy. That's not practical. What about the applications? Well, let's go back to what we talked about earlier, like battery and fuels, right? In batteries, energy density determines how much energy can be stored and how long a device can operate before needing a recharge. In other words, it gets annoying when you have your cell phone, you haven't charged it in a while, and you're down to 1%, right? Batteries are crucial for applications like electric vehicles, cell phones, portable electronics, laptops, so on and so forth. Fuels, in the context of fuels like gasoline or hydrogen, energy density is going to affect how much energy can be stored in a fuel tank, influencing the vehicle range and efficiency. In other words, if you have to keep refilling your car, that's not efficient, right? You want to be able to drive longer before you have to refuel. Capacitors. Energy density in capacitors impacts their ability to store and release electrical energy quickly, which is vital for applications requiring rapid energy discharge. What about energy density in different media, right? So here we talk about electromagnetic fields, which is EMF, right? Energy density is also used to describe the energy stored in electromagnetic fields. For instance, the energy density of an electric field, E, is given by 1/2 epsilon times large E to the second power, right? Where epsilon is the permittivity of the medium. What about in magnetic fields? The energy density of a magnetic field B is given by 1 over 2 mu times B to the second power, large B to the second power, where mu is the permeability of the medium. What about in cosmology and astrophysics? In cosmology, energy density is used to describe the distribution of energy in the universe. This includes contributions from matter, radiation, and dark energy, right? Our universe is filled with a lot of dark matter and dark energy. The energy density of the universe affects its expansion rate and overall dynamics. As we've been told time and time again, the universe is not constantly in the same position. It's expanding outwards over time, right? Suppose if you go with the Big Bang theory, it keeps expanding from that inner point. What about negative energy density? Well, this is where the energy density is less than that of the surrounding medium. Negative energy density plays a role in a lot of speculation, a lot of theories about things like wormholes or the Casimir effect, where quantum fields between conductive plates can exhibit a negative energy density, which is kind of a hard concept to wrap your head around because it's not something we're going to see every day. It doesn't act like things we see every day. What are the practical considerations? Understanding and optimizing energy density is critical for improving energy storage technologies. It's also going to enhance the efficiency of these devices that we use, and it's going to reduce the overall cost. So, research and materials from science engineering standpoint continually seeks ways to increase the energy density of batteries, capacitors, and other storage systems to meet the growing demand for high performance energy solutions. In other words, you want your laptops to go longer without having to be recharged. You want your cell phones to go longer without being recharged. You want your car to drive further and faster without having to be refueled. So energy density is a crucial parameter in various scientific and engineering disciplines, describing how much energy is stored in a given volume or mass. It influences the design, I'm sorry, I'm getting tongue tied, and efficiency of energy storage systems, which plays a significant role in theoretical physics. And this is fundamental to understanding and harnessing energy in both practical as well as cosmological contexts. Creating now exotic matter, now we are adding something new into the mix, right? Because now this is something that we would need for various speculative constructs, thought experiments in theoretical physics, right? Such as stable wormholes, which remain a challenge. Here's an overview of the concept and the current state of research, because right now, these are things that scientists have theorized based on the way things operate, that there should be these things in existence, but they are so uncommonly encountered. You don't run into this kind of stuff every day, right? You may not even run into this stuff over several lifetimes. So this exotic matter has properties, specifically negative energy density and negative pressure, which you're not going to find in everyday items. They do not act like this, right? And if you had that, you could probably stabilize wormholes to the point where they would actually be lasting, and you could counteract the gravitational forces that would otherwise cause such structures to rapidly collapse in the blink of an eye, or even less than that. Like let's say 10 to the negative 27 power in seconds, right? So what's the theoretical basis? The requirement for exotic matter comes from solutions to the Einstein field equations in general relativity. To keep a wormhole open, we would need exotic matter with such a negative energy that would then be used to create a repulsive gravitational effect. This idea has been explored, like I said, in theoretical models, in the thought experiments of scientists, but there's no empirical evidence that we have out there in the real world to actually show this stuff really exists and can be used. What about the Casimir effect? There's a phenomenon that hints at the possibility of negative energy densities through the Casimir effect. This quantum mechanical phenomenon is alleged to have occurred between two closely spaced conductive plates in a vacuum, resulting in a negative energy density between the plates. However, the energy scales and conditions required are extremely delicate and small, making practical applications challenging. In other words, you throw a lot of money at it and a lot of time at it, you might be able to make it happen with just a little tiny bit of time and then it's gone, right? It's not anything that we can use on a practical level, on a commercial level, anything in our day to day. What about quantum field theory? Quantum field theory now suggests that a vacuum fluctuations can produce negative energy densities in certain conditions. This is promising for future theoretical exploration by scientists, but harnessing these effects in a controlled and significant manner for creating exotic matter still remains beyond the reach of our current technological capabilities. Perhaps maybe something will happen centuries from now. I'll be long gone. I'll be, I guess, in the ground, and I'll have already decayed and turned into other things by now, right? What about the Large Hadron Collider, LHC? Researchers are exploring extreme conditions that might give insights into new physics, including the properties of exotic states of matter. However, creating stable negative energy densities or exotic matter, which is suitable for day-to-day applications like wormholes that you would like to have, right? You would love to be able to have these stable portals where you can go in one end and come out the other in mere seconds. But so far, we have not been able to create that, right? What about dark energy and dark matter? In cosmology, dark energy is hypothesized to have a negative pressure component, which contributes to the accelerated expansion of the universe. While dark energy is a form of exotic matter in a broad sense, its nature and direct applicability to creating stable wormholes or similar constructs are still unknown, out of reach, and right now are just the subjects of pure speculation. What are the future prospects? Well, the creation of exotic matter would require breakthroughs in our understanding of quantum mechanics, our understanding of general relativity, and also possibly new physical theories. Our research continues in areas like quantum gravity and high energy physics, and hopefully, this might one day lead to and reveal methods by which we can create or harness exotic matter. Wouldn't that be a wonderful day? In conclusion, Well, the concept of exotic matter is crucial in these theoretical constructs that scientists have envisioned like wormholes. Creating it remains elusive and an unsolved problem in modern physics and engineering. Current research is focused on understanding and detecting phenomena that suggest the presence of negative energy densities or exotic states of matter. Significant theoretical and technological advancements would be needed before the creation of exotic matter becomes a thorough and recognizable reality for us. That takes us to the concept of negative energy density, of which I will then end this video. So, negative energy density is a theoretical construct from advanced physics, particularly in the context of general relativity and quantum field theory. It does not correspond to anything in our everyday experience. And if it were possible to encounter or feel, the experience would probably be unlike anything we've ever known or encountered. Let's go into the speculative ideas that scientists have about what encountering negative energy density might entail. First off, we'll go to the gravitational effects. Negative energy density would have unusual gravitational effects. Instead of attracting masses like ordinary matter does, right? In other words, the Earth keeps us grounded, right? It pulls us towards the ground. It would repel them. So if you were near a region with negative energy density, you might feel a repulsive force pushing you away. This is completely opposite to the familiar gravitational pull we experience from objects with positive mass. Imagine you're going towards a planet, and every time you try to get closer to it, it's pushing you away, and you can never seem to get to it because the planet is so much more massive than you that it's repelling you at every turn. Physical sensation. It is challenging to speculate about a direct physical sensation since our bodies and sensory systems are adapted to the physics of positive energy and mass. In other words, we're used to gravity pulling us towards objects. We're not used to gravity pushing us away. I don't know that we would even know how that feels if we started to feel it, right? The effects on your body would likely be bizarre. They could even be potentially harmful given that our biological processes are finely tuned to the conditions of normal matter. We've evolved and adapted over time to adjust the conditions on this planet. Another planet that would have a negative energy density would be an whole new experience for us that might very well be lethal or fatal for us, right? What about the propagation of light and sound in strange ways? Light could bend in unexpected directions, leading to distortions or visual effects that are hard to predict. Sound waves might also behave unusually, perhaps failing to propagate in the normal manner or creating eerie and unfamiliar acoustics, right? Because again, we are used to light traveling in a certain way and sound traveling in a certain way. What about the time effects, the chronological effects, the temporal effects? This type of density being involved in exotic phenomena like stable wormholes, there might be bizarre temporal effects. For example, time might pass differently near such regions, potentially resulting in time dilation effects, where time slows down or speeds up compared to regions with positive energy density. Or you could even imagine time moving backwards, right? Almost like an anti time. That would be extremely weird and extremely bizarre, and we would not be used to anything like that. What about quantum effects? On a quantum level, negative energy density could lead to unusual fluctuations in a vacuum like state. You might experience strange quantum phenomena such as particles appearing and disappearing more frequently than normal, or quantum tunneling effects being enhanced in very, very strange, unexpected ways. What would be the overall impact on matter? Ordinary matter entering a region of negative energy density could experience unusual forces that might very well tear it apart or cause it to behave in unpredictable ways. Remember, our solidity is based on the way particles interact with each other, where there's a lot of empty space, but it's vibrating at a certain frequency, and that gives it the appearance of solidity. But under negative energy density, objects might very well be torn apart or even disintegrated or unstable, and definitely not very solid. Speculative technologies. If humanity ever harnessed negative energy density, could be used to develop technologies that defy current physical limitations, such as traveling faster than the speed of light or advanced energy manipulation on levels we've never known or encountered or been able to harness. The experience of using such technologies will likely be very alien to us and more advanced as the technology itself progresses. In summary, encountering negative energy density is at this point pure speculation, right? It's what our scientists believe to exist, but we don't have a way of proving it. We don't have the empirical evidence. Encountering it would be disorienting and hazardous. Uh, it would provide insights into how such an environment might behave, but without any empirical evidence or practical examples to rely on, any description that we have at this point is purely hypothetical. Our current understanding of physics and human experiences does not provide a direct analogy for what negative energy density would feel like. We're just so used to positive energy density, we've been spoiled on it, right? I hope this has been very helpful and entertaining to you. Please continue to like, share, and subscribe. I appreciate all your support for this channel. I love you and have a wonderful and blessed day. Woodman signing off. Take care.